Welcome to all. Today we are going to begin optical networks. Unit 1, Introduction to Optical Networks. The topics to be covered in this unit are telecommunication networks architecture, services, circuit switching and packet switching, optical networks, multiplexing techniques, second generation optical networks, optical packet switching, transmission basics, wavelength, frequencies, channel spacing, wavelength standards, optical power and loss, network evolution, non-linear effects, self-phase modulation, cross-phase modulation, four-way mixing, solitons, components, couplers, isolators and circulators, multiplexers, filters, optical amplifiers, transmitters, detectors, switches, wavelength converters, telecommunications network architecture. Here we will be seeing what is public network, private network, local exchange carriers, inter-exchange carriers. Public networks, the networks which are owned by government. These networks are operated by service providers or carriers. Carriers will be using their own network to provide a number of services to their users. For example, telephone companies are offering a number of services like voice, data. Today, carriers are dedicated to interconnect the internet service providers. Why means in order to provide a large bandwidth to other carriers. Virtual carriers are supposed to provide services without owning any infrastructure. The carrier owns the facilities. For example, it can be a fiber optic line, interconnects, and equipment deployed inside their network. Carriers may also lease the facilities from other carriers in order to offer a large amount of value added services by using these our leased facilities. Local exchange carrier offers local services in metropolitan areas. Inter-exchange carrier will be offering the long-distance services. Next is private networks. These networks can be owned by individual corporations or private companies for their own internal use. These corporations rely or depend on the capacity provided by the public networks like BSNL to implement their private networks. Local area networks, metropolitan area networks, wide area networks, command others we can say. What is local area network means? If it is covering a few kilometers, for example, within a college or within a campus means it is a local area network. Metropolitan area network. So these networks will be spanning to few hundreds of kilometers. Wide area network if we take means it will be covering a even more larger distance ranging from hundreds of thousands of kilometers. For example, it can cover a city. The nodes present in these networks, they are the central offices. They are called by points of presence. Long haul network. This is used to connect different cities and it can extend to thousands of kilometers between the central offices. This diagram shows the different parts of a public network. Public network can be composed of long haul network, metropolitan area network, wide area network, and so on. So, this is a long haul inter-exchange network. This forms your metropolitan area network. This is a central office at the point of presence. This is a metropolitan access network. This is the individual user. Next, services. Services are classified as connection-oriented services and connection-less services. In connection-oriented services, first a connection has to be established between the users. Only then data transfer can take place. There is connection between two or more parties across the underlying network. The differences lie in the bandwidth of connection and the type of underlying network with which the connection is supported. This has an important effect on the quality of service offered by the carriers to their customers. Next is connectionless services. Here authentication is not needed. Packets of same message is considered as a different entity and it can be sent in different path. But in connection-oriented services, authentication is needed. Only after authentication only data transfer will be taking place. Next is circuit switching and packet switching. So let us define what is a circuit switch network. Here the connection is established by using switches, we can say. Here, a guaranteed amount of bandwidth is allocated to each connection and this amount will be available as long as the connection is there. Once the connection has been set up, this guaranteed amount of allotted bandwidth will be there. The sum of bandwidth of all circuits or connections on the link will be less than the link bandwidth. That is, the bandwidth allocated to a particular link can be shared among the circuits within that link. That's all. Example, public switch telephone network. The circuit switching is not as much as efficient. Why means there is difficulty in handling bursty data. Next is packet switching. Packet switch networks. Here, the data stream is broken up into a number of small sized packets. These packets are joined or multiplexed, combined together from other data streams inside the network. The packets are switched inside the network based on their destination. To facilitate this switching, a packet header is just added to the payload in each packet. The header, what is present inside the header means address information will be present. For example, the destination address or the address of the next node in the path is present. The intermediate nodes read the header and determine where to switch the packet based on the information present inside the header. At the destination, the packets belonging to a particular stream will be received and the data stream is put up together. Example of packet switch network is your common internet, which uses the internet protocol. What is protocol? It is a set of rules in order to route the packets from their source to their destination. Sometimes the packets may be queued or buffered. If the link is not available, a link is not free. When the traffic is high, it causes buffers to overload. So when this is happening, some of the packets must be dropped from the network. Usually, a high-layer transmission control protocol in the internet detects this development and ensure that these packets are transmitted. Thank you.